Welcome to Mathematics Online Lecture Series by Professor K.V. Narasimhan. Vector Calculus, Lecture number 31. Vector Integration, Lecture number 11. So today's topic is Gauss Divergence theorem. So we have three integral theorems. One is Gauss Divergence theorem, second one is Green's theorem, third one is Stokes theorem. So we will discuss these three theorems one by one. First we will discuss about Gauss Divergence theorem. This Gauss Divergence theorem relates with triple integral and double integral, which relates between triple integral volume integral and surface integral. Then what is the statement? Listen carefully. Listen. Now this is x-axis, y-axis, x-axis, y-axis, z-axis. Suppose we have a surface S. Okay. S is the surface. Three-dimensional surface enclosed in the volume. Inside is volume B. Okay. Nothing but closed surface. Closed surface. Okay. Fine. If f is continuously differentiable, f of x, y, z is continuously differentiable vector point function. Okay, already we discussed earlier. Then what happened? Triple integral of divergence of V over the volume B equals to double integral of f dot n ds over the surface S, where n is the unit outward normal to the surface. Where n is the unit outward normal to the surface. Okay, I will repeat again. Let S be a closed surface, enclosed a volume V, okay, which is shown in the diagram. F is continuously differentiable vector point function. So a vector point function is defined on this surface. Okay. Then integral divergence of f dv is nothing but triple integral of divergence of f dv equals to integral f dot n ds over s is nothing but double integral of f dot n ds, where n is the unit outward normal to the surface S at any point in the surface S. Okay. Now this is called Gauss Divergence theorem. Now I will repeat again. Triple integral of divergence of f dv equals to double integral of f dot n ds. So this theorem relates triple integrals and double integral with some condition. What is the condition? Triple integral of divergence of f dv equals to double integral of f dot n ds, where n is the unit outward normal to the surface. Okay, now we will discuss about most important question. Okay. Listen carefully. First question. Verify Gauss Divergence theorem for this function f equals to, for the function f equals to, what is the function f equals to x square minus yz into y plus y square minus zx into j plus z square minus xy into k. This is the f is given. Taken over the rectangular parallelepiped, x is 0 to a, y is 0 to b, z is 0 to c. Then what is the diagram? Okay, I will take one diagram. I think this is better. Listen carefully. I will draw the rectangular parallelepiped. nothing but rectangular box. And it contains total 6 surfaces. This is X, I will take Y, I will take Z axis. O is the origin. So, up to A only. Now this is A00, 0. I will call it as capital A. This is capital C, capital B, capital C. Similar problem is discussed in surface integrals. Now, C is a point on y-axis 0, B 0. P is a point on z-axis 0, 0, C. B is a point in xy plane A, B 0. S is a point in yz plane 0, B, C. Q is a point in xz plane A, 0, B, 0, C. Now R is a point in xy, A, B, C. So this is rectangular parallelepiped. We have total 6 surfaces are there. So first the S1, this part, this is S2, S3, S4, so front S5, back side S6. Total 6 surfaces are there. So what is the Gauss divergence theorem? Here we will prove that triple integral of divergence of FdV equals to double integral of f dot n ds. Okay. So we will verify Gauss divergence theorem. First we will find the triple integral. Later we will find the double integral. Now first, divergence of f. Divergence of f. Divergence of f is nothing but dou by dou x of x square minus yz plus dou by dou y of now jth quotient y square minus zx. Dou by dou z of z square minus x. Now if you simplify 2x, this is 2y plus 2z. Nothing but 2 times of x plus y plus z. Okay. After finding the divergence, we will find the triple integral. Triple integral of divergence of f dv equals to 2 into triple integral of x plus y plus z dx dy dz. X is 0 to a given, directly given, y is 0 to b is given, z is 0 to c is given. Now first integrate with respect to z, then integrate with respect to y, then integrate with respect to x. Okay. 2 into x is 0 to a, y is 0 to b, z integration xz plus yz plus z square by 2. 0 to c dx dy. Now substitute z equals to c. 2 times of x is 0 to a, y is 0 to b, here x z, xc plus yc plus c square by 2. Now dy dx. Now integrate with respect to y. Now integrate with respect to y. X is 0 to a, integration with respect to y. Xc into y plus y square by 2 into c plus yc square by 2 0 to b dx. X is 0 to a, so y equals to c, y equals to b, bcx plus b square c by 2 plus bc square by 2 into dx. Now, with respect to x, BC x square by 2, B square C by 2 into x, BC square by 2 into x, 0 to a. Now, if you substitute the limits, x equals to a square BC by 2, a B square C by 2, a BC square by 2, here 2 cancel, ABC is the common term, ABC into a plus B plus C. So, what is the integral value? Therefore, a triple integral of divergence of f dv equals to a plus ABC into a plus B plus C. Okay. Now, verification of Gauss Divergence theorem. Nothing but finding the double integral with respect to each and every surface. Already we discussed in surface integral. So, one by one. Over the surface, first surface, A, B, R, Q. Already we discussed in our earlier class. A, B, R, Q. In this surface, what about N? What about X? What about Y? What about Z? So, already discussed. So, unit outward normal to the surface is, unit normal is I. Now, if you observe X coordinate is A, Y varies from 0 to B along Y axis, along Z axis 0 to C. So, N equals to I, X is A, Y is 0 to A, and 0 to B, Z is 0 to C. Now, what is F dot N? So, ith coefficient of F is x square minus yz into I plus something, y square minus something. So, with dot product with I is nothing but x square minus yz. Already x is known, a square minus yz. Now, double integral f dot n ds over the surface a, b, r, q, double integral a square minus yz into varying variables are dy dz, y is 0 to b, z is 0 to c, integrate with respect to z, 0 to b, a square z minus yz square by 2, 0 to c into dy. Now, y is 0 to b, a square c minus c square y by 2 into dy. Now, integration with respect to y. A square c y minus c square y square by 2, already 2 is there, 0 to b. So, a square b c minus b square c square by 4. Okay. Now, this is first surface integral. In the similar way, over the surface, now second surface, we will discuss all the surfaces. Now, this surface, O, C, S, P, O, C, S, P, N is M equals to minus I. So, X equals to 0, Y varies from along Y axis 0 to B, Z Z varies from 0 to C along Z axis. N equals to over the surface OCSP. OCSP. N equals to minus I, X is 0, Y is 0 to B, Z is 0 to C. F dot N equals to, already discussed in the earlier previously, with negative sign, minus X square minus Y Z. Already X is 0, so Y Z. Now integration. Double integral f dot n ds over the surface OCSP equals to double integral y is 0 to b, z is 0 to c, yz dz dy. Z integration y is 0 to b, y z square by 2. 0 to c dy. So, c square by 2 into y is 0 to b, y dy, c square by 2 into y square by 2, 0 to b. So, this integral value is b square c square by 4. Double integral of f dot n ds over the surface OCSP. OCSP equals to b square c square by 4. In the previous problem, second term is minus b square c square by 4. Both are cancelled if you add all the values. Okay, we will discuss later. Now third. Over the surface. Now third surface, and then what is here, and etc. Now SRBC. In SRBC, n equals to j, y equals to b, if you observe. Now x along x axis 0 to a, along y axis 0 to c. N equals to j, n equals to j, y equals to b, x varies from 0 to a, y varies from 0 to c. F dot n equals to, so jth quotient is y square minus xz. This is plus y square minus xz. Okay, I will take it. Y square minus xz, jth quotient. Now integration, double integral f dot n ds SRBC. SRBC, okay. SRBC. Here y is b square minus xz. So b square minus xz, this is z, dx dz. Z is 0 to c, x is 0 to a. Now first integrate with respect to z. X is 0 to a, b square z minus x z square by 2, 0 to c. Integral x is 0 to a, b square c minus b square x by 2 dx. B square cx, b square x square by 4 0 to a. So a b square c minus a square b square by 4. Now this is third value. I think the fourth value. Now over the fourth surface. Over the surface. Again same. PQAO. Here y equals to 0. Y equals to 0. Along x-axis 0 to a. Along y-axis 0 to c. The unit normal is, outside normal is n equals to minus j. Surface PQAO. PQAO. n equals to minus j, y is 0, x is 0 to a, z is 0 to c. F dot n equals to minus of y square minus xz, that is xz, because y is 0. Double integral of f dot n ds over the surface PQAO equals to double integral of xz dz dx. X is 0 to a, z is 0 to c. So here integration is x square by 2 0 to a, z square by 2 0 to c. Now finally a square c square by 4. Because both are not dependent variables, so we can separately integrate. Now this is next value. Fifth, over the surface PQRS, front part, PQRS. Same procedure, n equals to k, x is 0 to a, y is 0 to b, z equals to c. Now check it. Here z is c. Along x-axis 0 to a, along y-axis 0 to b. Then find f dot n. Right. After that, add all the 6 values, you will get the surface integral. Double integral of f dot n ds over the surface PQRS. X is 0 to a, y is 0 to b, f dot n, okay, f dot n equals to z square minus xy, kth coefficient of f. Z square is already known, c square minus xy. C square minus xy dx, dy dx. First integrate with respect to y. X is 0 to a, c square y minus x y square by 2, 0 to b dx. X is 0 to a, b c square minus b square x, b square x by 2 dx. Now integrate with respect to x. bc square x b square x square by 2 0 to a. bc square a minus b square a square by 4. Now this is sixth integral value. Now last surface over the surface OABC backside surface, n equals to minus k, z is c, z is 0, x is 0 to a, y is 0 to b. F dot n equals to minus of z square minus xy, that is x is already now 0, so z is 0, xy. Double integral of f dot n ds over the surface OABC equals to x is 0 to a, y is 0 to b, xy dx dy. Now already known, both are separate, not dependent variables. Simply x square by 2 0 to a, y square by 2 0 to b. Finally a square minus b square by 4. So now this is seventh integral. Therefore double integral of f dot n ds over the surface s equals to first integral, second integral, third integral, fourth integral, fifth integral and sixth integral. Okay, I will call it as S1, S2, S3, S4 and instead of S or B and etc. Now first value, first integral value, first surface integral value, a square bc minus b square c square. A square bc minus, I think b square c square, b square c square by 4. b square c square by 4. Second integral is b square c square by 4. Now third integral is abc square minus a square c square by 4. Next integral is a square c square by 4. Next integral is abc square minus a square b square by 4. Last integral is a square b square by 4. Now these two cancel, these two cancel, these two are cancelled. Finally abc into a plus b plus c. So double integral of f dot n ds. Then what is the observation? This is the eighth integral. What is the first integral? Therefore triple integral of divergence of f dv value is abc into a plus b plus c. This is same as double integral of f dot n ds. Now then what do you say? Triple integral of divergence of f dv equals to double integral of f dot n ds. Hence Gauss divergence theorem is verified. This is most important question for examination point of view. Now I will discuss few more questions. So those questions are homework for you. I will give 3 homework questions, but I will give the hints. Now observe, here f is look like similar one like our previous problem. Here cube is given, all sides are given and x coordinate planes. Same procedure in our previous problem, a equals to b equals to c, a equals to b equals to c, same diagram, same procedure, but f is totally different. Now fifth question is also f is totally different, but again cube is given, x is a, y is a, so both the diagrams are same. These two problems diagrams are same. Cube diagram, all sides are equal. In our parallelepiped, put b equals to a, c equals to a, you will get the same diagram. So f is totally different question is given. In the third question, f is given, but here again cube is given, but whose side is 1 only. In the previous problem A, this problem 1 only. So these 3 problems are homework. Try it, but it is very easy. Okay, thank you. Meet again. So we will discuss the another model in the next class. So these 3 problems are look like our previous one only. Just try it, otherwise ask me directly. My email ID is narasimhan_kv@yahoo.com, or my phone number 9866278504. WhatsApp to me. I will clarify your doubts. Okay. Thank you very much. Okay, I will stop here. In the next class, we will discuss another problem in Gauss Divergence theorem.